For 50 years, the Boeing 737 ruled the skies as the world's default narrow-body jet. But today, airlines from India to the Gulf are tossing out their 737 orders, replacing them with a new jet that is rewriting aviation's balance of power before our eyes. The stakes? A duopoly shattered, billions in play, and safety doubts that just won't die. But what triggered this exodus? And could Boeing's fall signal the end of an era, or just the start of a much bigger upheaval? A commercial jet worth $100 million vanishes without a trace, not from a war zone or a remote airstrip, but from the heart of the world's most closely watched supply chain. The aircraft is discovered months later, stripped to its bones in a warehouse in Jiangsu province in China. Every panel, every rivet, every circuit board systematically dismantled and catalogued. French intelligence officials, including former DGSE chief Alain Juillet, described the operation as textbook industrial espionage. Their investigation uncovers a pattern: Western aerospace technology, reverse-engineered piece by piece, with the aim of replicating not just the plane, but the entire ecosystem behind it. Airbus executives testify that export controls tightened immediately after, forcing suppliers to restrict the transfer of their most advanced engines and avionics. The message from Europe's aviation giants is blunt: trust is broken. When an airliner can disappear and reappear as a blueprint for a rival, every shipment, every contract, every handshake is suddenly suspect. This is not just a story about a missing jet. It's a warning shot across the bow of international aviation. The fallout ripples through boardrooms in Toulouse and Seattle as Western manufacturers scramble to defend their intellectual property. For the world's airlines, the question is no longer just about price or performance. It's about whether the next plane they buy is truly theirs, or just the latest chapter in a global contest for technological supremacy. For nearly 6 decades, the global airline industry revolved around two names: Boeing and Airbus. Nowhere was this rivalry more entrenched than in the narrow-body jet market, the backbone of short and medium-haul air travel. The Boeing 737, introduced in 1968, became the workhorse of commercial aviation, with over 10,000 delivered across every continent. Airlines from Seattle to Singapore built their operations around the 737's reliability, familiar cockpit, and vast pool of trained pilots and mechanics. Flight schools, maintenance shops, and leasing companies all invested in the 737 ecosystem, creating a network effect that made switching costly and complex. Airbus entered the race in the late 1980s with the A320, but for decades, the market remained a two-horse contest. Duopoly's grip was so strong that airlines often chose between the two, not just for performance, but for convenience, commonality in pilot training, spare parts, and scheduling. This stability extended beyond airlines. Airports, regulators, and financiers all planned around the predictability of the 737 and A320 families. Even as new models arrived, the core dynamic held. The 737's continuous upgrades, from the classic to the next generation to the MAX, kept it relevant, while Airbus matched every move with its own innovations. By 2015, more than half of all commercial flights worldwide were operated by either a Boeing 737 or an Airbus A320. The idea that any other jet could break into this stronghold seemed far-fetched. The narrow-body market wasn't just a business, it was a global infrastructure, engineered for continuity and scale. Any disruption here would send shockwaves through every level of the aviation industry. On October 29, 2018, Lion Air Flight 610 plunged into the Java Sea just minutes after takeoff, killing all 189 people on board. Less than 5 months later, Ethiopian Airlines Flight 302 crashed outside Addis Ababa, claiming another 157 lives. Both disasters traced back to the same aircraft, the Boeing 737 MAX. Investigators found a critical flaw in the Maneuvering Characteristics Augmentation System, spelled MCAS, a software band-aid installed to compensate for the MAX's larger engines and altered aerodynamics. The system depended on a single angle of attack sensor. If that sensor failed, MCAS would force the plane's nose down, overriding the pilot's attempts to climb. Internal Boeing memos from 2015 to 2017 reveal that some engineers warned of this vulnerability, but management prioritized speed to market as Airbus's A320neo racked up orders. After the Ethiopian crash, aviation authorities in China, Europe, and eventually the United States grounded the entire 737 MAX fleet. For 20 months, more than 380 jets sat idle, the longest grounding in American aviation history. Airlines scrambled to rearrange schedules. Boeing halted deliveries and faced mounting lawsuits. Congressional hearings uncovered a company culture where production deadlines and cost control eclipsed safety concerns. Engineers described pressure to shortcut testing and downplay risks to regulators. The FAA's certification process came under fire for relying too heavily on Boeing's own assessments. By the time the MAX returned to service in late 2020, trust in Boeing's engineering had been deeply shaken. The company's once unassailable reputation for safety now stood in question, and competitors saw an opportunity to challenge Boeing's hold on the world's air routes. Airbus engineers spent years refining the A320neo family, chasing every percentage point of efficiency they could wring from the design. The leap came from the engines, LEAP 1A and PW1100G models, each with a bypass ratio up to 11:1, far higher than what the 737 MAX could accommodate. That technical detail translates to real-world savings for airlines. On typical routes, the A320neo burns 15 to 20% less fuel than its predecessor, and often edges out the MAX by 2 to 3% per seat. For a low-cost carrier flying hundreds of cycles a week, that difference adds up to millions in annual savings. But it is not just about fuel. Airbus designed the cockpit so that pilots certified on one A320neo can fly any other model in the family with a single type rating. That means a captain trained on an A319neo can switch to an A321XLR without retraining, and airlines can schedule crews across the fleet with maximum flexibility. Maintenance teams benefit too. Shared parts, common procedures, and longer intervals between heavy checks keep jets in the air and out of the hangar. For airlines, these upgrades are not just technical milestones. They are the answer to volatile fuel prices, growing environmental regulation, and the need to launch new routes on short notice. The A320neo's efficiency, commonality, and operational reliability give airlines the confidence to retire older jets and expand into markets where every cent counts. In a world where delivery slots are scarce and margins are thin, the technical edge of the Neo is more than a selling point. It is a survival tool. June 2023. The world's largest aircraft order is signed in a conference room in Paris, and the future of commercial aviation tilts east. Indigo, India's low-cost juggernaut, commits to buying 500 Airbus A320neo family jets, enough to build an airline from scratch, or to redraw the route map of a continent. The deal is the product of months of marathon negotiations between Indigo's chief executive officer Peter Elbers and Airbus's sales chief Christian Scherer. Both men know what is at stake, not just the next decade of Indian aviation, but the global balance of power in the skies. The numbers are staggering. At list price, the order is valued at more than $50 billion. Insiders say the real leverage comes from slot guarantees. Airbus promises Indigo early delivery positions, leapfrogging hundreds of smaller buyers. In a market where airlines wait years for new planes, that promise is more valuable than any discount. Financing is orchestrated through a web of sale-leaseback deals, with leading lessors like BOC Aviation and SMBC Aviation Capital stepping in. The structure lets Indigo scale its fleet without tying up capital and shifts residual value risk onto financiers hungry for exposure to India's booming market. This is not just about adding capacity. Indigo's contract includes substitution rights, allowing it to swap between A320neo, A321neo, and the long-range A321XLR as network demands change. Older A320ceo aircraft are retired early, keeping the average fleet age under 4 years and maximizing efficiency. Every detail is calibrated for flexibility, growth, and dominance in a country where air traffic doubles every 5 years. For Airbus, the order locks in years of production and sends a message to rivals. In the world's fastest-growing aviation market, the A320neo is not just winning, it is rewriting the rules. Airlines and lessors make their intentions clear, not with press releases, but with purchase contracts. By the end of 2025, the global order books tell a story that numbers alone cannot disguise. Airbus holds more than 9,700 firm orders for the A320neo family, nearly double the 4,500 committed to the Boeing 737 MAX. Cirium's industry databases, along with company disclosures, confirm this gap. These are not speculative letters of intent or headline-grabbing options. They are binding agreements, net of cancellations and conversions, that dictate what will fill the world's skies for the next decade. This gulf is unprecedented in the history of commercial aviation. Only a few years ago, the narrow-body market was a dead heat, with Boeing and Airbus splitting orders almost evenly. Now the A320neo backlog stretches from Toulouse to the horizon, while Boeing faces a queue that grows thinner with each new delay or cancellation. Analysts from Aviation Week and Lessor Reports agree, nearly two-thirds of all single-aisle jets on order are Airbus, a dynamic not seen since the A320 first entered service. The numbers are more than a scoreboard. They shape the future of airlines, airports, and entire economies. For every airline chief executive officer or fleet manager, the size of the backlog means more than just bragging rights. It determines who gets new jets first, who can launch new routes, and who must wait or compromise. Leasing giants, who control the fate of hundreds of aircraft, are shifting their portfolios to match this new reality. A senior executive at one top lessor put it bluntly, "Backlogs mean nothing if you can't deliver. Real fleet managers judge on output, not promises." Boeing's 4,500 MAX orders still represent a formidable business, but in this market, scale is everything. With nearly 10,000 A320neo aircraft in the pipeline, Airbus has seized the initiative. The order book is not just a reflection of past events, it is a map of the next era in global aviation. China's ambition to challenge the Airbus-Boeing duopoly rests on the shoulders of the COMAC C919. But beneath the surface, a hidden dependency shapes every aspect of the program. The C919's airframe may be assembled in Shanghai, yet nearly 91% of its components are sourced from Western suppliers. The engines, avionics, landing gear, and flight control systems all arrive from a who is who of the global aerospace supply chain: CFM International, Honeywell, Liebherr, and Rockwell Collins among them. Each supplier brings not just parts, but intellectual property, export licenses, and legal restrictions that limit what COMAC can truly claim as its own. The illusion of a thriving domestic jet program is reinforced by a crowded order book. COMAC lists orders for more than 850 C919s, but a closer look reveals that 23 of the 24 official customers are either state-owned Chinese airlines or leasing companies tied to government banks. These entities operate under central directives, not open market competition. There are no binding orders from major international airlines, and no evidence that independent lessors are willing to gamble on a jet so tightly controlled by Chinese policy. This structure creates a paradox. The C919 is championed as a symbol of national achievement, yet its fate is dictated by foreign technology and government-mandated buyers. Without access to the latest engines or avionics, and with its customer base confined almost entirely to the state sector, the C919 faces a credibility gap that no amount of domestic fanfare can close. For airlines outside China, the question is not just about the plane's performance, it is whether the aircraft will ever be truly independent of foreign supply chains and political orders. Engineers at CFM International designed the LEAP-1C specifically for the COMAC C919, but the engine's potential is deliberately restricted. Unlike the LEAP-1A and LEAP-1B, which power the Airbus A320neo and Boeing 737 MAX with bypass ratios up to 11:1, the LEAP-1C is contractually detuned. Export controls and supplier risk management mean China receives a version that delivers less thrust and lower fuel efficiency. As a result, the C919's advertised range hovers near 3,000 nautical miles, a full 1,500 miles less than the A321 XLR, and several hundred miles short of the Boeing 737 MAX 8. This technical gap is not just a matter of numbers on a spec sheet. For airlines, every mile of range translates into new route possibilities and higher aircraft utilization. The C919's limitations force operators to accept payload penalties or skip lucrative city pairs altogether. On top of that, the engine's lower efficiency means higher fuel, eroding the razor-thin margins that define low-cost and regional carriers. Maintenance planners face additional headaches, as the LEAP-1C lacks the global support network and the reliability data that airlines expect from Western models. In boardrooms across Asia, Africa, and the Middle East, these constraints make the C919 a non-starter. Airlines running fleet simulations see the numbers: more fuel burn, fewer profitable routes, and uncertain support. The technical promise of a homegrown jet is undercut by the reality of a foreign-sourced engine, stuck a generation behind its Western siblings. Airbus's ability to deliver jets at pace has become the deciding factor for airlines racing to capture post-pandemic demand. In 2025, Airbus prioritizes mega buyers like Indigo, Flynas, and AirAsia, slotting their orders ahead in the production queue while smaller carriers and latecomers wait years. Monthly output now averages more than 50 A320neo family aircraft, a figure Boeing has struggled to match since the MAX crisis. Boeing's own cap of around 38 MAX jets per month, compounded by ongoing quality issues and regulatory scrutiny, leaves airlines with little choice if they need capacity today. Flynas, the Saudi low-cost carrier, illustrates the calculus. Facing rapid growth and fierce competition, Flynas executives opted for the A320neo family, citing not only fuel savings but the certainty of delivery. Their 120-jet order, structured with options and rapid conversion rights, allowed them to flex capacity as the market rebounded. In Southeast Asia, AirAsia's leadership points to Airbus's delivery reliability as the single most important factor in their historic fleet transition. When the MAX grounding left airlines in limbo, Airbus filled the gap, offering near-term slots and flexible financing. Delivery reliability became the decisive selling point. Industry analysts warn the production gap is not closing soon. Richard Abulafia, a leading aviation forecaster, projects that Boeing's output will lag for the rest of the decade, with no new narrow-body design arriving before the late 2030s. For airlines, the message is clear. Availability is not just a procurement detail. It shapes route launches, market share, and even survival. In this race, the jet you can fly now is the only one that matters. Today, over 9,700 Airbus A320neo jets are on order, twice Boeing's 737 backlog. As airlines race to modernize, decisions made in boardrooms now will shape global air travel for decades. The skies are no longer a duopoly's domain. In this new era, innovation and trust, not legacy, decide who leads. And the balance of power is still shifting, one delivery at a time.